Hello, Mona, can you hear me?
I can hear you. Can you hear me?
Okay, great. Hello, everyone. Welcome to session one for day one of PyCon Indonesia 2020. My name is Zaki, and I will be the moderator for this session using Python to create a local law in New York City by Nurvirta Monarizqa. Mona is a data scientist with years of experience working in multiple domains such as urban planning and cybersecurity. And on this session, she will tell us about one use case of data and Python to create a local law related to urban planning. And now she's here with us in this room. You ready to deliver the talk, Mona?
Yeah.
Yeah.
I'm excited. Looking
Okay,
forward to it.
great. I'm going to share your screen.
Sure. Oh, I can see it now. Great.
Great. Okay, without further ado, the stage is yours, Mona. For the participants, you can keep those questions coming on Hopin platform, and our team will collect them and we will discuss it in a Q&A session. Let's give a big round virtual applause to Nurvirta Monarizqa.
Yay. Thank you. Thank you. That's really helpful, by the way. Um. All right. Let me start. Boom. Okay. Hi everyone. Good morning. Good afternoon. Good evening. My name is Nurvirta Monarizqa, but you can just call me Mona. It is my nickname since I was born, I guess. So you can call me Mona. Just call me Mona. I'm a data scientist for 4 years now, I believe. As mentioned before, I've been working in a several domains, in urban planning and cybersecurity. So I started when I was in college. So I graduated from information technology Universitas Gajah Mada, and then I graduated, and then I continue to the grad school. I went to NYU, New York University, Urban Informatics, and I got my first job as a data scientist in urban planning there. Um, but currently, I'm not working in that company anymore. I'm not working at Microsoft. But in this talk today, I'm not gonna represent Microsoft. Um, I'm gonna tell you a story about a project that I'm the most proud of, and as as the title of this talk, it is about creating a local law in New York City. So if you're here because of the title of my talk, the clickbaity title, then congrats, you're here. Succeed to lure you to this talk. Uh, but actually, it's not just a clickbait. It is true. If you search on the internet, you can search Bill 1574A. So it is a local law that divide New York into 20 non-exclusive zones. For commercial waste zones, each surfaced by up to three corridors. Like, what the heck is this? I'll tell you later on. So basically, long story short, the zoning itself is a system to divide an area into several areas. So to think about zip codes, code posts, but this is for garbage collection. So in New York City at the time, it is everybody's game. So if you want to be a carter, so we call company that collects commercial waste is a carter. So if you want to be a carter, you can just register your company, you can buy a truck, and then you can just collect the garbage on the street. Everybody can do that. So it is very, very open. Even though it was regulated, it is very, very open. And um by the history, um, it was in the 80s, 70s. I guess it was regulated by the mob. So if you watch movies about New York City, about movies about like the Italian mobs, the gangs, they were the ones who rule this garbage collection area. But then the city regulated, so everybody has to register it. But again, it's still creating a lot of problems. It has safety problems, transparency problems, equity problems. um, what I mean by safety is because it is highly competitive, a truck from one area can goes all over the city to pick up the garbage. So imagine if you're in Jakarta, for example, a truck can collect the garbage, commercial garbage in this case, from I don't know, probably somewhere in Jakarta Utara to Bekasi in one night, in one day, and it is it is take toll on the safety, transparency, equity, all of these problems, and the city decided to, you know what, screw it, let's just create zoning. So in the future, only a certain carters can operate in a certain part of the city. So this is the comparison if you're not familiar with with New York City. So the left hand side is Jakarta. So in the right hand side is New York City. So New York City itself, as you can see, it is bigger than the Jakarta, the province. But it is probably roughly the same areas as the Jakarta, the metropolitan area, the Jabodetabek. And New York City consists of five different boroughs. Boroughs is like the city within city. So we have Staten Island, Manhattan, Brooklyn, Queens, and Bronx. And this is the visualization on what what the city wants to achieve. So basically, in the future, we don't really want a truck, a garbage truck from a carter goes all over the city to pick up garbage every single night. It will be more regulated, more condensed in a certain area, so that the traffic is lower. The safety is up, and it is more easily regulated, I guess. All right. So if you're not familiar with this kind of job, you might be wondering how we got job at the first place. Um, so I was working in a civil engineering firm. So the way the civil engineering jobs is is um is obtained, the way we got this kind of job, usually the city or the city agencies, whatever it is, the governments, they basically open a request for proposal. So they have these certain jobs, and the civil engineering firms, or yeah, basically all the firms, they have to compete for the proposal. In Indonesia, usually heard something like tender or something like that. It is similar. And then once you get chosen, you'll get a job. And my team at that time, we did a data driven approach. It was comprised of, I think, 5 6 young people at the time in the team. And we thought, oh, it might be interesting if we can get a twist in this proposal. We'll get the data. We will create the zoning based of the data, not only pen and paper, the traditional way. And it succeeded actually. The city saw our proposal, and they thought it is very interesting, and we got the job. And here is our proposal actually. So our idea is we're going to separate New York City into small areas. So if you see the small areas here, we call it community district, and then we will merge the nearby area. So we will basically cluster the areas. Um, Based on a certain metrics. The first is the customer count, and the second is how often the customers from these areas or from the neighboring community districts got picked up together by route. Um, I had a hunch in this proposal if because I believe at the time a truck or a company, they don't usually go all around the place just erratically. Um, they usually have a certain place as their base, and they usually just serve that base, that certain areas. They don't really go all over the city. So we don't really want to make the carters angry, and we want to have the middle ground here. So the middle ground is we want to keep those bases as much as possible. So we want to create zone areas that satisfies both our client, which is the city, and the business, which is the characters. So why we use data? First, data won't lie. I mean, yeah, I mean, you can lie with data, whatever, but um, data generically won't lie. What you see is what you get. And the second one, it can create a strong arguments because we're dealing with the mobs. Basically, we're dealing with the gangsters. We want to create a strong argument so that in the future, if they sue us, hopefully not. We have strong arguments. We use data, we use analysis and stuff like that. So you can do something about it. And then why Python? Um, so Python actually is now gaining a popularity in the geospatial area because it is free compared to the competitors. For example, ArcGIS. I mean, we have QGIS, but I mean, people in the industry they usually use ArcGIS or MATLAB, but Python is free. So who doesn't like free stuff? And then it is flexible. We can use APIs, we can use libraries, and anything like that. And in this specific project, we use your maps API, and ArcGIS doesn't support your maps API, I believe. So why use ArcGIS? And then multifunction, we can do analysis, we can do visualization, we can do everything basically. If in the future they want to, for example, create a zone dynamic, yeah, we can deploy that possibly in the future. I don't know, but I don't work there anymore. So, uh, and these are all the libraries used. So in this presentation, you won't see any Jupyter notebook. You won't see any codes or anything like that because I don't really want to make this a very tech heavy. I want to make this a light presentation so that you can just follow along, and we have a discussion, more open discussion later on. But these are all the libraries that I used. Um, Standard, Matplotlib, Volume, GeoPandas, Shapely, Pandas, NumPy, sklearn, Yarlib, SMNX. These are all the libraries that are usually used for geospatial project, especially GeoPandas, Shapely, Volume, Matplotlib, and OSMNX. And then the data that we use at the time, we use two types of data. We have the customer data from each carter from the company that run the business of collecting garbage, and then we have routes for each night, for each truck, each carter for 2 weeks. So we have a giant CSV for each carter, each truck on where they're going every night. So it is usually an address, the name of the establishment, stuff like that. And we used pandas, osmnx, and urllib to do geocode and data cleaning. So in this presentation, I will not show you my code or anything like that, but I'll show you the libraries that I use and the method how I did it in the past. All right. So the very, very first tab, so our client is really interested in the vehicle miles traveled. We call it VMT. Basically the traffic, how we quantify the traffic, because he wants to know if we do this zoning, how much traffic will be reduced in the future. So first thing first, we have to calculate the vehicle miles traveled, and we use here Maps Trucks API because trucking in New York City has many restrictions. So, for example, they're not allowed to go to some streets and stuff like that. And Google Maps can't do that. ArcGIS cannot do that either. Um, so we use Human Abstract API. It was the only API that we can use that complies with all the trucking stuff in New York City, basically. And it is able to route up to 125 points, I believe. So we use here Abstract API, and then we use GeoPanda, Shapley, Matplotlib to then plot the thing and stuff like that. So if you see any visualization in this presentation, everything was built or everything was created using Python. This is one of the example. This is purely Python. This visualization is purely using Python and GeoPandas. Nothing about like Adobe Illustrator or anything like that. Example: beautiful visualization using Python. So the second step is we search all possible zone combination for each borough. So as I mentioned before, borough is like a city within a city. It's like kecamatan maybe. So there are five: Manhattan, Queens, Bronx, Brooklyn, and Staten Island. So for every single borough, we look at the neighboring borough. So for example, but by looking at the routes, we're looking at the pattern, how often this community district usually group together. So for example, oh, it turns out in in community district 101, 102, 104, there are 500 trucks that usually go around this area, picking up from this area. And those customers add up to 8,000 customers. And we do that for the other combination 101, 102, 103. How many routes um, that usually go around that area every night, and how many customers potentially being picked up in that area every night. And we do that for every single combination that is possible for every borough. And then the step number three, we create the combos. Once we search for all the possible combination, we gather all the information that we have, and then we create all possible combinations. So we have like 50-ish combination, I forgot, that is possible based off of the requirement by the client. So the clients wants the zones to be same in same size in terms of the customer count. So we make sure the customer count for each zone is fairly similar. So what we did here, once we search all of the combination, we try to visualize every single one of them and look what is possible. It's like playing puzzle, but instead of using pen and paper, instead of using an actual puzzle, but it was all done using Python, literally on keyboard, and visualize them using GeoPandas and Volume. And and it's not um one time job, so we do that multiple times. The first time we have five candidates in the left corner side, and we ask our client, are you satisfied with this, and stuff like that. We have back and forth. So we have the second version, which is the upper right hand side, and then finally we have a final version, which is the version in the lower left side. So we do back and forth with the client collaboration, like the theme of this PyCon ID. So with the Python and combination with the back and forth with the client, we finally have the zone that we want. And the fourth step, we try to simulate the VMT after the zone is applied. So now the question is, if we use this zone configuration, which is the one in the left bottom side right here, how how much traffic will be reduced? How many vehicle miles traveled will be reduced? So in order to figure out how to calculate that, we create simulation. So if we have only one character finally occupying a zone, so think about, for example, in the future, let's say kantor pos, they can only serve Jaksel, for example, Jakarta Selatan. Then what will happen? And we thought, by looking at the data, by looking at the behavior of the big characters, they usually quite smart. They usually cluster the customers that are nearby together, so they pick up the garbage every night. So the very ideal condition, if we have only one carter, is to just cluster them up and then route them, and then we calculate the vehicle miles traveled. So this is for one carter, and I use escalon cluster to cluster the customers at the time. And if we have two carters, it gets a little bit complicated because now there is a competition. You don't you don't have the luxury to then cluster everything into a beautiful cluster anymore and then just pick them up. You have to compete with other carter. So with that, what will happen is there are going to be some mini cluster, but the cluster will be bigger. If previously um, eight the very clustered eight customers will be served by one truck from one carter, in the future the nearby 16 customers, they will be served by two carters. So the cluster is bigger, but there will be some degree of clustering, and the way these two cluster I'm sorry. The way these two carters will compete with each other is just like random. And then if you have four characters, it will be a complete mess. Basically, if previously 16 customers in a very secluded area will be served by two characters, in the future, double that, 32 customers will be served by four characters. So they have to compete with each other to pick eight customers at a time. So after we have this in our mind, after we figure out how's the behavior in the future, we calculate the possible traffic in the future by using here maps again, GeoPanda, Shapley, Matplotlib, and this is the result. Turns out we'll decrease the traffic by 63% by using zoning. And these are all the key takeaways from the project itself. So it turns out using Python is cheap and scalable and fast, because if we use RGS, for example, or any other competitors, because we try them all. Trust me, we try them all. Um, we can get to analyze 10,000 routes as fast as we scheduled, and we cannot get these 50 zone combos, obviously. And then the second key takeaway is the data product is convincing and powerful because our client really, really like it. Our client really like how we approach everything with data so that they have a strong argument just in case somebody sue them. So it is hard to refute. And if we look at the history, in the Pakistan and India border, I just know that um, in like 70 years ago, I believe, they were separated by a boundary commission that relied on an out-of-date maps and census materials, which obviously in the modern world that can be avoided with the most updated data and with Python, for example, maybe. I don't know. And Python can be used for a greater good. So if, for example, not everyone can contribute open source. Okay, because I mean everyone can contribute open source, but again, maybe not everyone can do that because of like many reasons, whatever. But you can always use Python if you are a user. Use it for something good. Use it for a greater good because it is an open source. From 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 us to us, um so just use that for the benefit of the greater good. And in this case, I was able to create a local law to support a local law by creating the zones by using Python, and it benefits 8 million people in New York City. And I can't believe I can do that because who am I? I'm just a I'm just a lady, a woman from Indonesia, a country that you've never heard of, but you can do that um, in a big city. And then this is the example of the zones. This is the final version of the zones. Again, this was built using Python. I mean, this was created using Python, Pandas, Matplotlib. Everything is in Python. And if you are interested in the nitty gritty, in the technical stuff, how we did it and stuff like that, you can always download the appendix here. It is open. It is out there in the open. So everything that I present to you is open. You can always download it. You can always read it, and all the methods are there and stuff like that. So you can read that in your free time, if you will. And special thanks to my previous employer, Arcadis, because without their permission, I can present this. So I'm really grateful of the opportunity, and thank you for everyone who's listening to me today. Hopefully, you get something, and um, shoot me a question if you have any.
Well, thank you, Mona, for the amazing talk that you have shared with us. It certainly opens a new perspective for us in a way that Python can be used not on Python and data can be used not only for a marketing or any commercial uh, business, but also for creating a local law that really benefits and contribute to the society and community. Now we've already got some questions regarding the talks, and I'm going to go for the first question here.
Mm-hmm.
First question from Tombo Yu. For your case, why use Python and not use R, for example?
Yeah, a good question. So at the time, I did compare R with Python. I did compare everything. I did compare all of the tools that I can use. Um, Unfortunately, at the time, R cannot support our needs at the time, so we wouldn't use R. But I believe if 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 you can, if it is if you can use R for your use case, that was good. No problem with that. But at the time, it wasn't it 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 didn't met our requirements at the time. Um, to create the zones, visualization, all that stuff. I think probably you can do that now, but at that time, I couldn't do that, and that's why I use Python.
So,
Mhm.
because of more of a visualization side of Python, so you choose Python instead of R back then.
Yeah, and I think at that time,
Mhm.
I mentioned at that time because
At that
I
time.
don't really I'm not really into following the R development right now. But at that time, the geospatial world, I mean, in the geospatial analysis and stuff like
Mhm.
that, the Python side has more libraries that I can use, has more
Mm.
capabilities. I mean, ArcGIS use Python for for their stuff as well. So that's why we use Python at that time.
Okay,
Hmm.
interesting. Interesting story about Python capabilities, like one language to rule them all. Then, second question from Chitra. Does the map API you use here free?
Mm, good question. So yeah, so we have many options at the time. Again, I did compare everything. So here I mention um, OSMNX in one of my slide because that's the alternative. So here maps which I used at the time, it wasn't free, so I have to
Mhm.
pay I have to pay it, but it's not as expensive as ArcGIS or Google Maps, for example. It was cheap at that time, so we used that, and it was fast. But if you really really don't have money, you can use OSMNX. It is pretty similar. It was built by Geoff Boeing, I believe. He's a professor, um, somewhere. I forgot, in either in northeastern, northwestern, or Berkeley right now. But he built the package that basically can do routing, can do graph analysis and stuff like that, based off of OpenStreetMaps. So if you really don't want to pay anything, you can do OSMNX.
Okay, so OSMNX is like a free, powerful package that we can just use, and it's also open source.
Yes.
Yes. Okay. And about the map API, the paid map API that you use, is that you pay once and then you can access all features, or is it priced by request, for example?
Mm. Yeah, good question. At first, we use by the request,
Mm-hmm.
but I mean, we analyze 10,000 routes and we do simulation for, I don't know, 50 different cases. So
Mm-hmm.
we know it's gonna be expensive for us. So we had a deal with a company with Here Maps. So we have a 1 year deal that we can have some kind of like unlimited request. So that's how we got it.
Okay.
Hmm.
Cool. And then question from Irvan Putra: will there be public continuation of this project? And if there will be, where's the repo?
Mm-hmm. Yeah, yeah. So the public continuation is in the future. I'm sorry, I don't put that here. But in the future, it will be implemented. So it should be implemented next year, I believe. So next year. So if you are a carter, so if you are in the business of garbage collecting, you won't be able to collect the garbage from Bronx to Staten Island anymore. You have to register. Basically, you have to get franchised for a certain area. So that's how it works. That's how it works. The maps itself is somewhere in the open data New York, so you
Mhm.
can always look at the map in the open data New York. And the documentation, as I mentioned before, I have links for the documentation. You can always see the methods there. And for the repo, just because the data and everything is very sensitive. We
Mhm.
got the data from the city and from the carter itself. So we can't really publish the repo. So there's that.
Okay, so
Yeah.
for the audience, if you want to see the map, you can see it in open map. Is it
Yeah, in New York City Open Data. So
New
New
York
York
City
City
open
has a
data?
portal. Yeah, has a
Mm-hmm.
portal of Open Data, and if you search um, commercial rezoning, there will be a map which was created by me. So there's that. And if you want to know the methods, the logic behind it and stuff like that, you can look at the documentation, the PDF documentation, which I shared to you earlier.
Okay.
Mhm.
Remember, New York City open data. Go there and you can access the map publicly. Then, from Kiki, can you apply this technique as it is in Indonesia? If not, what is the challenge maybe?
Good question. I believe you can. There's nothing blocking you technical wise.
Mm-hmm.
The I mean the the technique, the method is there up there in the internet. You can Google it. You can download the documentation. You can always look at it. Um, the the tool is free, Python, so you can always use it. So technically, you can always apply it. You can apply it in anywhere, like in any city, as long as you have the same data. For example, you have carters, and it works that way. It works in an open market and has the same basically the same condition. But the question is, Would you be able to convince the government to do the same? That's a different question. Or will
Yeah.
you be able to land a contract with your government to do that? It's a different question. But these days, I think cities in Indonesia, for example, Bandung, they have like Bandung Digital something something, I forgot. So in the government, they
Mhm.
have this digital division, which is now enabling interesting project like this to be able to be implemented. So I'm optimistic in the future we will able to do something similar in Indonesia.
Okay, so Kiki, that's the answer for your question. And then, oh, this is a really interesting question. Are there any special techniques in cleaning data and analysis, especially when using data from the API map from geospatial analysis cases?
Mm-hmm. Oh, so for this one, yeah, I mean it is actually hard to clean the data from the API itself at first. I'm sorry. I was struggling at first just because at that time it wasn't a field that people just do. So it was a little developed at the time. It was very hard to get the documentation, especially for heat maps. Um, but these days, I believe you can get the documentation easily. People are
Mhm.
starting to use more and more, so you can just look up on the internet on how to clean it. And I have so this is my personal project. So I have a repo under my name on GitHub. So I have one repo called weekly stash phase, where I did some visualization for some just special visualization and stuff like that, based off of your maps as well. So if you're looking for like specific for here maps, I do have some examples on how to clean those kind of data. um, but it is different from API to API. Yes, it is hard. Yes, it is involved in. I mean, you need to do trial and error on that. But I believe there's somebody on the internet that has done something similar. So you just need to search it.
Okay, so
Mhm.
I'm actually wondering, were you involved in all the parts from cleaning the data and stuff, or you just use the data that is already cleaned by other data engineer, for example?
Ah, I'll be very happy if that's the case, but that's not the case. So in this case, the the, the data that we got the data from the carters, basically the business that running these carters, running these
Mm-hmm.
trucks. They're not. I mean, most of them are not really internet savvy even, so they have to manually put the data in the Excel file sometimes. I mean, if we got a good CSV from the carter, we'll be very very thankful, but that's not the case. So we still have to clean it. We still have to figure out what's going on in this data. We still have to merge them all, geocode them, and all the processing that's needed to make it usable.
Well, you sure got a lot of experience on that project. A lot of
Yeah.
things to learn from that project. And another question from Chitra. Are you using any method to measure this recommendation effective enough, like accuracy
Yeah.
testing method, basically?
Yeah, good question. So this is actually a good this project is actually a good practice for me to basically figure out what is actually important. I thought as a data scientist, for example, accuracy testing method, or precision, whatever it was the most important. Turns out it is important, but it really depends on your project. It really depends on, for example, if you have a client, what your clients need. um in cybersecurity, for example, I mean, I am not working in the cybersecurity. Accuracy is not important. The important is, for example, the positive recall, how many, or the positive precision, how many how many malware that we can catch, how many positive malwares that we can catch, given our detection, for example. So it is really really different from company to company. It is really different from project to project. And this project is accuracy and stuff like that is not important at all. The metrics that my client wants, um,
Mhm.
is the reduction of the traffic, uh, which
Reduction
is
of
very
the traffic.
interesting. So that's why when we evaluating all 50 different combinations, we look at them, and then we model the traffic. We calculate the traffic after the zoning, and that was the metrics for my client. So my client will look at the traffic, which one will give the most traffic reduction, and which one will give the best distribution of the customer, for example. So it is really different from your usual data science project.
Okay, so for this project, the client will focus on traffic reduction. So it
Hmm.
will be different method for different project, depends on what we want to achieve. Is that
Hmm.
what you're saying?
Yes.
Yes. Okay. So and then I believe you've answered this question previously. What is your report or output to the client for this project? There is a New York Open Data,
Mhm.
which we can access publicly. And Muhammad Saif Sifaul Rizki, that's the answer for your question. You can go to New York Open Data if you want to see how the map looks like.
Yeah, and the local law, because this is the at
Oh
the end
yeah,
of the
the local
day,
law
the
is also
product is the local law. Yeah,
and in the end of the day, the product is the local law.
yeah.
Interesting. Okay, Mona, what an awesome, great session. Unfortunately, we ran out of time. Thank you so much, Nurvirta Monarizqa, Mona, for your talks today, and also for all who participate in this session. Allow me to close this session quoting from Mona. If you're
Mhm.
able to use Python, just use it for greater good. So explore Python, use Python, and contribute to the community using open source, for example. Okay, to all of you, see you in the next session, and goodbye.
Thank you,
Thank
everyone.
you.